Go ahead and explain what it is that you're doing.
Yeah, so right now I'm working with this bot right here, and I'm writing a program to reposition these 4 colored cubes using a suction cup tool to position these 4 in 2 stacks of 2 blocks each. And so I'm writing that using different waypoint positions with the program here. And once I've got all those positions set up, I'll be able to run that program and test it and see if I need to change anything. And just a quick positioning thing. But that's the thing, once you know where they need to be positioned, you don't really need a sheet anymore. But I can just use a program to find the positions.
What I did was I took this robot from the home position, and then I used free drawing so that I could basically position it. And then when I did that, I was able to position it in a certain way so that I could basically bring it from different waypoints. And every waypoint that I did, I had to use a certain move. For this one, it has move L, which is just linear, and all the moves are just in a straight line. And as it moves in a straight line, it just goes to different waypoints. As it moves, the different joints just are able to, I guess, configure in different ways so that it's able to move smoothly. If it had a problem, it would just crunch up, or it would just tell me on the teach pendant, but because it doesn't, it just moves smoothly.
So we're working with a articulated robot, which is a 6-axis robot. The students get to learn about the various types of movements the robot can do. Here, what we are trying to do is make the robot move in a simple pattern, that is along the edges of a square or a rectangle or a quadrilateral. So the students have already programmed the points into the program. These robots need to know something known as coordinates that help the robot navigate along the edges of whatever shape you provide. Once the students provide this, they can first simulate it on the teach pendant so that they can test it and make sure that everything is going well. Then they can download the program to the robot and let it run and test. So what we're trying to do here is upload the program to the robot and let it work. What you're seeing here is the robot moving along the edges of the quadrilateral, one step by one step. It begins at a home point, waits for a couple of seconds, moves to a second edge and third edge, and completes the fourth edge. The simplest of programs that the students learn about. One major aspect of this learning process is where the students need to figure out 3D coordinates in a space where there is no reference point. So that becomes a part of the learning process where in the classroom we discuss all the details about basic algebra and geometry-based coordinate systems so that the students can get used to teaching the robot where to go and what to pick up and what.
And then what would this be used for in an actual plant or business?
In the real world, there are plenty of applications. For example, based on the movements that you can see, if you imagine that there is a planar surface right in front of the robot, we could actually have a laser installed as the end tool or as the tool at this point and let the robot engrave something on that planar surface. That's only one of the tools among many tools that are available. Now, sometimes in mechanical systems, they also use cutters placed as the end tools so that this planar surface can be cut into whatever shapes we would like to. At the same time, you can also have drawing tools connected to these systems so that you can have the robot draw various patterns or create various shapes or let's say figures. So the students need to again go through the same process. It's the same process for all programming. However, the students will have enough information during lecture sessions to make sure that they can create all these patterns within these programs.